Whoa, what's going on here? Wait, why is this doing this? Eighth grade, take out that worksheet. Your math assignment from yesterday was, in fact, a worksheet. Little surprises around every corner. Don't worry, nothing to be afraid of. For those of you that aren't with us, this is for you. I'll take them. Answer today's worksheets. Technically, you don't need a name.
Hey, no, excuse me.
Welcome to my world. Robin, is this?
Someone let me know.
No, you have two.
No, I only have one.
Wow. That means the name of the topic. There is no name.
Wait, I ran out. Who's got two? Somebody has to have two different ones, because I don't have. I came up with. Somebody's got to have it. Fess up, somebody out there. Otherwise, Sam, you're just gonna twiddle your thumbs till somebody figures it out. All right. Here, stop. I only need you to stop. I wouldn't care, but I'm recording this, and that really is irritating to anybody recording. So if you can't not click it, find a different, correct your thing. Here's what you're going to do, ladies and gents, in case of all ages. I'm going to read the answer. If the person who you are grading it missed that one, you're going to stand. Now, if for some reason you cannot figure out where their answer is, please don't ask me where it's at, because we'll stop with the clicking. Did I not just say that? Wait till I'm done with this whole lesson, and then you can click. Regret the day I ever gave you any presents. Number one. So if your person missed this, please just stand quickly. I'm just going to record how many people missed. Number one should be x is 1, y is -7. I think I did that one for you, maybe. Did I? I did? Wait, everybody got it right? Wow, congratulations. 2, for some reason I messed up. 3, the slope is, again, I could have this wrong because I just did this very quickly. So if everybody's wrong, it's probably me. 7/4. Nobody knows who that is. So I'm just going to jot this down. 2. That helps me out. Number 3. Wait, that was 2. Oh, that was 3, right? Number 4 is y equals 1/4 x plus 1. Wait, does anybody have that answer? Does somebody actually have that answer? Do you think I'm wrong, or do you think somebody else is wrong? I could be wrong. We'll look at that one. Let's see. 1, 2, 3, 4, 5, 6, 7. Ooh, this is exciting, isn't it? Especially since we got a lot to do today. Perpendicular line. Ooh, I predict a lot here. How about y equals -1/3 x minus 1? 2, 4, 6, 8, 10, 11. Could be me. Number 6, it's a negative correlation. I get something, I don't know, I don't want to, you get a whole bunch of dots that look like this, and a couple dots that look like this, and a dot that looks like that. Let's just call that good. I won't spend forever on that. Number 7 is not a function. Anybody? That's that one. 8 is a function. Oh, people. People.
Well, there's 3.
There was 3?
Yeah.
Well, who's slow on this whole thing? Number 9. There's going to be a bunch here. There might be 1 or 2 where everybody misses it, or I could have gotten it wrong. When the graph to the right is positive, that would be when is the line above the x-axis. When x is less than -1, you can put equal to, I don't care if it's equal to, or when x is greater than 2. Wait, nobody missed that one? Thank you. 2, 4, 6, 8, 10. Oh, good. We are right on this. When is it increasing, ladies and gentlemen? That means it's going up, starting right here to right there. I'm going to guess that that is, if you actually do that, when x is greater than 1/2. Or equal to, I don't care. Did everybody get that wrong? We did get a couple rights? Good. 2, 4, 6, 8, 10. Maybe I'm wrong on all of these. Number 11 is 8. Function of x is 8. We know what we know. Number 12. Graphing that thing looks like this. -2 means it goes down 2. It is, this negative means you go +3, so down 2 over 3. It would start right here, and then it has a slope of 2, which means it goes up 1 over 2, so it's going to look a little like this. Anybody? 4. Some progress is made. The range for this problem here is basically what can the y values be? What are the y values here? Well, it starts at -2 and goes up, so the range means y has to be greater than -2 or equal to, I don't care what you want to do there. Anybody? Nobody missed that one? Ooh, again, we're making progress. Number 14, I have y is greater than -6. 14y is greater than -6. Oh, maybe I got this wrong. Did I get this wrong? 2, 4, 6, 8, 9. The only thing I see is that not everybody got it wrong. So, number 15, ladies and gentlemen. 15, I have between -6 and 10. -6 and 10. I could have failed this, by the way. As an answer. Still waiting for the one I got wrong. 2, 4, 6, 8, 9, 13. Nobody's standing. So far, not one person has been missed by everybody, so I might be okay. Oh, number 16, you're going to laugh. It's 16, I have -6 to 0, and it's colored in between. Wait, did I do better on this one? 2, 4, 6, 8, 10. Number 17, this one, again, I'm going to wonder about this one. This is what this one is. X equals D over 5 plus 10F. I'm just happy if somebody gets these right. 2, 4, 6, 8. Number 18, this would be the one where either I got this wrong or all of you will probably get this wrong. Ladies and gentlemen, number 18, there's no solution. Stand up if the person did not put no, did anybody put no solution? Oh, good. I could be way wrong, but we'll talk. This is one we're definitely going to do. This would be the first one I do. You can tell me if I did something wrong. Number 19, again, I did this in a hurry this morning. I get for number 19, x is 0. And ladies and gentlemen, number 20, x equals 40. We get that one wrong. Yay! Now, try to figure out whose paper you got and give it back. If somebody not give me a paper, I don't understand how I could collect them all and redistribute them all and Sam not end up with one. Sam, any idea how that would happen? We will answer all questions right now. Eighth grader, there's an outside chance that I failed this quiz and got all those wrong, but I don't know. Remember, every day is a learning day. You do this enough times, you'll go, oh. Did anybody get ice?
This is mine. This is mine. I don't know. I had ice.
Huh?
I got a paper.
Kelsey seems to have a paper with hers.
I think this is yours.
I handed out everything I took, so there's got to be papers floating around. If you don't have all your stuff, somebody's got to have papers floating around there. You were there when I asked. What, Stone? 4 again. Y equals 1/4 x plus 1. Sam, I gave back every paper I was given. I did not keep any. They threw them all out there somewhere. There's no possible way, everybody, you should not give back the paper you gave me, because I literally gave out every paper I had there. Did everybody come back with something here?
Yes, I did.
Wait, Avery, you just have an extra?
I need the. It has.
Oh, the test?
Some of it has like the answers.
I might have the, oh, there it is. Sorry, Avery. I just thought it was a test. Wait, Sam, did you get yours back? Right there, hey! I said we were. Oh, I don't, wait,
0x equals 16.
I said I could have done it wrong. Maybe I did it and I just wrote, maybe I read the wrong answer. Wait, for 19?
Yeah.
Oh, yeah. 19 should be no solution.
Yeah, I went right there.
I thought you said Chris.
Sorry. I told you I couldn't have it wrong. Now, let's take a look at problem number 18. I think you're gonna laugh. Just remember this. The fundamental rule is, if in fact I did this right, what is the rule number 1, Ike, when you're solving absolute value equations? Step number 1 is to, well, what do we call that in math? Isolate the absolute value, right? So to do that, what do I have to do? Subtract 7, right? 3 minus 7 is what? One more time? A little bit louder.
-4.
And the rule is, ladies and gentlemen, an absolute value can never, ever, ever equal a negative number. Once you got to that point, x plus 4 equaled a -4, it can't happen. Absolute value turns everything to positive. So no matter what happens inside of here, no matter what numbers are in there, they're always going to end up being positive. So this can't happen. Hence the reason. No solution. Don't you feel that you've become wiser, smarter, and more intellectual? We We should probably work our way back. I just hoping you gleaned something from this. I don't know if we address it again. Problem number 17, if you missed it. I don't know how many of you did. Was it a significant number? It looks like 12 of you. Let's see. I'm trying to figure out a way I can do this where you can actually see it. Where's my shapes? Hold on. Yeah. Look, children. Look. B equals 5x plus 10xf. You are supposed to solve for the letter x. Somebody tell me what they did. What if you got this wrong, tell me what your first step was. Lila.
Subtract 5x and then
Okay, but what does that prove? Okay, so you subtract 5x over here, which is logical. I get d minus 5x equals 10xf. Now what do you do?
then I subtracted the d.
The d, okay. Now you subtract the d and you subtract the d. So now you have negative 5x equals 10xf minus d. Now what?
Then I try to divide it by negative 5x.
All right, but if you divide by negative 5, ladies and gentlemen, you have not solved it for x because there's still an x over here.
So just do that.
Thoughts on that? The only way, ladies and gentlemen, let me throw this at you again. The only way, if you have two different terms that have an x in it and you're trying to solve for that, the only way that that's ever going to work is if you can factor that letter out, reverse distributive property. In other words, we're going to change colors just because. In other words, sorry, that's the wrong thing. So I need to do this. D equals, I take the x out of both of those terms. I end up with a 5 plus 10f. Now, the x is by itself, and I can just get rid of the stuff next to the x because this is x times that. I could just divide this whole thing by 5 plus 10f. That goes away, the x is isolated, and now you still have the 5 plus 10f at the bottom over here. So this is what x would equal. Make any sort of sense? If I can just get a little small bit to you each and every time we do this, do not feel bad that you missed 17 out of 20 or whatever. Well, you should feel bad if you missed 17. But as long as you gained some sort of wisdom today, besides the fact of clicking your pens the whole time. What else we got? If they want me to buzz over, they don't understand what happened at some of these. Nobody had anything? Wait, which one did miss the most? Oh, let's go up to the 13s. Because I could have possibly gotten this wrong. Just quickly, what would we happen here? These compound inequalities, they're a common thing in math. They're not anything abnormal. If you have this, what do you need to do? You need to isolate the variable. I got to get this p by itself. What do I do to get rid of it? What do I have to do first? Liam Bocek? Minus 8 on both sides, because it's actually a combination of two equations. You subtract 8 on both sides, you end up with negative 12. 2p. Oh, anybody else have 2p? Usually that gets a little more laughter than that. And then, Anna, what do I have to do to solve it from there? Just divide both sides by 2. And you are now solved. You get negative 6 over here, 5 over there, p there. Is that what I said the answer was? I hope. So from negative 6 to 5, it's colored in. Oh, and 13 of you got this wrong? Maybe I did this one wrong. Let's do this one too. Did you do the distributive property and get 20 plus 5y is greater than 2y plus 14? Did we get that starting point? Maybe I did this wrong. Now what do I have to do? Move my y's to the left side, so I subtract 2y. I subtract 2y, which gives me 3y. I subtract 20 to get it to the other side. I subtract 20, I get a negative 6. Divide by 3. Divide by 3. Did I say the answer was y is greater than negative 2?
Less than.
Less than what? Was this the answer? We'll see. There we go. How many people actually got it right? see, why didn't you, somebody should have like yelled at me. Told you I did it really fast. It can happen. See, now you know why I got a C in Algebra 1. Didn't follow my own rules. Sam?
For number 14, why don't you add things?
Don't I add what?
Like, why don't you add the 5 and the 2y?
Because you have to think about the inequality is like an equal sign. Move this over there, you do the opposite. Just like an equal sign would. Sam?
And then for 18, you're telling me that if the equation has, like, let's say 2 numbers outside of the absolute value zone, if the first one you do makes it negative, it's automatically no solution, even if the other letter.
I am telling you, if you isolate the absolute value sign, okay, and by isolate, I mean, it doesn't matter what's in the absolute value sign, it means there's nothing outside of it on this side. Okay, if you isolate that and on the other side, somehow you get a negative number, it's impossible to do. Because an absolute value makes everything positive. If you have a negative out there, it can't be done because there's no way that'll ever happen. Wait, did I miss 2 on that already? Are you keeping score?
No.
Okay, good. Did I miss another one? Who's out there? Somebody want to challenge me on one?
15.
I should intentionally miss them and then make you see which ones you challenge me on. Kavara, can you challenge me on one?
No, it's the 2d10.
Can I do 10? Oh, yeah, I can do 10. Number 10, I hope I got right. Although maybe not, because then we got it wrong. What does increasing mean? Increasing means that it is positive slope. Increasing means that from left to right, it is going uphill. If you look at this graph, where is it going uphill? It starts going uphill right here. On this other side, it's going downhill. So that's negative slope. So at what point does it start doing that? Right here where x, if I asked you for that coordinate point, you'd say that's 1 comma, what is it? I got to erase it because I lost it. That's 1 comma negative 2. So where x is 1, it starts going uphill. In any place greater, when x keeps getting bigger than 1, it keeps going more uphill. So any place where x is greater, it's 1/2. Then 1/2. It's between 0 and 1. Okay, anybody put 1? Okay, no. You can help me out with the,
Oh.
Anything on the first page while I'm there? I'll do one more before we forge ahead to new and uncharted territories. Ladies and gentlemen, back to this one. Why is this one not a function? Why is that element not a function? No, it doesn't matter about patterns. The only way on a table you can tell if something's not a function is, Lila?
The 2 different ones that are 1 have different y.
Okay. You only need to look at the x. If there is the same number x that goes to different number y's, then it's not a function. Which makes sense because if you think about the graph of this, the graph of this point is 1 comma 5, 1, 2, 3, 4, 5. And the graph of this is 1 comma 20, which means way up here at 20. That would defeat the vertical line test, because if you drew a vertical line there where x is 1, it would hit both of those dots, and that can't happen with a function. Same thing why this one was a function. There's no place you can draw a vertical line where it crosses it more than once. It might look like it does, but it don't. Now you're saying, hey, let's do something new.
Let's do
I didn't hear you say that. Now you give me something. You know what we need to do, kids? Go ahead and ask. We have solved equations by 2 different ways. Systems of equations by what 2 different methods? Uh-oh. Oh, no. That was the thing that didn't print.
No.
That's all right, you can write it down. Take out a blank piece of paper. I had a handout, but I'm just gonna give it to you. Maybe we'll get through it, maybe we won't. This is what the piece of paper should have looked like and it should have said. Maybe you'll get lucky and I won't get very far. So far, children, so far we have solved systems of equations. First of all, we graphed them, correct? Do you remember where the lines crossed? That was the point that we gave as our answer. Yesterday, we solved by substitution. Today, children, we go to the third way, which is by elimination. And it is today that after we talk about this, you will tell me, why did we ever do it the other two ways? Okay. And here is the basic, it's based on this principle, ladies and gentlemen. If you have two equations, let's go with something very easy. 2 plus 3 is 5. And that is an equation because it has an equal sign in it. Kavar, give me another equation. 4 plus 2 is 6. Okay. If you add these two equations together, you also get another equation that is equal. That's true. Is 6 plus 5 11? Yes. So if you use that principle and add two equations together, and if by some chance one of the terms drops out, one of the letters drops out, you can solve it for the other letter. Case in point, look at this first one. If I have those two equations and I add them together, negative 3x and a negative 2x is a negative 5x, right?
Yeah.
A positive y and a negative y actually go away because they're opposites. Thank you for cheering for that. And then over here, a negative 12 and a negative 3 is, and then lo and behold, you can solve that for x. Even Kavarik would tell you that x is divide by negative 5, divide by negative 5, so x equals a positive 3. Now you're not done just because just like before, you're looking for an x and a y value. You are looking for the place where when you graph those two lines, they cross. So you need to figure out what the letter y is. But just like yesterday, if you figure out 1, you just need to put that 3 into one of the other two equations and figure out what y is. Now, again, you can help yourself out a little bit here by picking the one that probably is the easiest. Any suggestions? Would you rather put it into this one or put it into that one? And why? Anderson, you seem disinterested. Why? Top or bottom? Why? I'd go with the top. Do you want to know why?
Why?
Because my y would be positive and I wouldn't have to worry about dealing with negatives. But either one's going to work. All right, so here I go. I'm going to do the top. I'm going to put x in right there. Negative 3 times 3 plus y equals negative 12. Which means I get negative 9 plus y equals negative 12. Add 9, y equals negative 3. So there are my answers, 3 comma negative 3. That means when I did graph this, the lines would have crossed somewhere down there, however that worked. What do you think of that, kids? Don't worry, we got more. Where is the other one? How about this one? Adding them together, I get minus x plus x is no x's. 7y plus y is, or 6y plus 1y is 7y, and 5 minus 5 is zilcho. Can I do that problem? Yes, I can.
Yeah.
You can divide 0 by 7. You can't divide 7 by 0. The answer to this would be y equals 0. And that'd be pretty easy to figure out what x is, because if you put 0 in for y here, what do you get? X plus 0 is 5, so x equals 5. Now, you are saying, surely it can't be this easy.
Surely it can't be this easy.
You are right, and don't call me Shirley. All right? Because this is what's going to happen. Well, maybe it doesn't happen on this one. I probably should have looked before I talked to you about what happened here. Oh wait, did you write this one out? Okay. Write that one down on your little piece of paper. Again, I should have had the handout for you. For those of you following along at home, it's been an invigorating and exciting lesson so far. Even Emma Martin is smiling. Not very much, though. All right, now, if you look at this, ladies and gentlemen, and you add those together, look what happens. Negative 8 and negative 7 is negative 15x. Negative 7 and negative 7 is negative 14y, and negative 8 and 0 is negative 8. Does that help you out? It doesn't, because none of the letters were eliminated. So Christopher Anderson, is there something, a solution to this by chance that you could think of that could help us out just a teeny bit? All right, I will tell you. First of all, I'm going to get rid of this. Okay. In order to eliminate something, ladies and gentlemen, get this in your little noggins. In order for this to work, you have to have opposites. In other words, if I have an 8x up there, I have to have a negative 8. Okay? Or vice versa. Or if I have a negative 7, one of these has to be positive 7. Well, children, there's a little thought, and we've done this before, that you are allowed to change equations if you multiply or divide every term by the same thing. In other words, if this was a positive 7, wouldn't my life not be so much better? Yes. Well, what do I have to do to this to get it to be a positive 7? Just multiply it by a negative. Okay, or negative 1 if you want. I'll do that. Negative 1. But the rule is, if I multiply one thing by negative 1, I have to multiply everything in that equation by negative 1. So I have to do every term by negative 1. So what's going to happen is this. This becomes a positive 7x. This becomes a positive 7y. This stays 0 because 0 times negative 1 is still 0. So now you can think about this equation as being completely gone. And now elimination will work because you still have this equation here, minus 8x minus 7y equals negative 8. These things, when you add them together, these two will be eliminated. You get a negative x equals a negative 8, which means a positive x equals a positive 8. Am I done? No. I then have to take my 8, plug it into either one of the two, or even this one. It doesn't really matter. Shall I do? It doesn't matter. Let's put it in this one. Can I go back where it was 7x plus 7y equals 0? If I put 8 in for x, 7 times 8 is 56, I hope. I subtract 56 over there. Subtract 56 over there. If 7y equals 56, what's y equal? Look at the negatives fly. Y equals negative. Stop it now. Whew. Time for a deep breath. Now, surely you're going to say it can't be that easy. Well, it's still not quite that easy, and still don't call me Shirley, because this, ladies and gentlemen, is going to be the granddaddy of them all. Oh wait, this is not the granddaddy of them all. Well, I was hoping that this one happened, but apparently it did. I'm sorry. Luckily, you got here just in the nick of time. Not time to go call me Nick. Oh, hard. What was that saying? Who left? Chris laughed at that.
I laughed at that
Oh,
one.
maybe this is it.
I laughed at you too.
Maybe this. Okay. So here we are at the same little situation here again. We're trying to get them to be eliminated. Nothing would be eliminated if I added them the way that they are there. Emily Robbins will tell me I need to do what?
Multiply by negative.
And I'm going to say, Emily, which one do you want to multiply by -1? Top or bottom? Does not matter. Although, if you look ahead a little bit, you could probably make life easier by which one you pick. It doesn't matter. Emily, which one would you pick? The top. I'm with you on that. Why? Because this would make this a -18, and that would actually give you a positive answer there. So, I'm going to multiply everything by a -1 on the top. And then I'm going to rewrite it underneath right here, make my life easier. This becomes a positive 6x. This becomes a positive 3y. This becomes a -18. Hip, hip, hooray. I add these together, I get a -x. This is eliminated, as our problem says, and this becomes a positive 3. So what is x? X would be a -3, because you can switch those signs. Am I done? I'm not, and don't call me Nick. So for x, I'm going to put -3. It doesn't matter. You could pick any of these three equations to figure out what y is. It doesn't matter. I'm going to pick this one. I'm going to take 6 times a -3 plus 3y equals -18. So it gives me a -18 there, plus 3y equals -18. I should have you get out your little Chromebooks and graph it and see if this actually crosses at this point. Add 18. Oh, look, what's that? Y equal? Anybody? Anybody joining on the 0 bandwagon?
0.
I believe y does equal 0. Now, one more. This one is not even on my sheet. Somebody say, Nick, surely that can't be this easy. No, Nick, surely that can't be this easy. Call me Nick, and surely it's not. Write this one down. -8x plus 2y equals 20. I hope this works out. I really should have. -5x plus 5y equals 20. Oh. Huh. I'm just pulling one off of the worksheet here. Okay, here's where Lila says, what? Because there are no opposites there. What is the fix? How do I make opposites? Oh, wait, we have a fix? Robbins?
Well, -8 plus 2. What? No.
No
Sam?
solution?
No. There's going to be a solution. Whether it's a good one or not, I don't. Reagan? Multiply by -1? Which one? All right, if I multiply the top by -1, I'm going to do this in blue. I'm going to take Reagan's advice. I get a 8x minus 2y equals -20. Now, Reagan, let me ask you a question. When I add those together, which one's going to be eliminated now? Let's try a different philosophy. Who's got another suggestion? William Bochek.
Divide both y's into the answer. Like divide 2 into the answer and divide 5 into the answer.
Ooh,
Ah. And then multiply by.
you know what?
Yeah, okay.
I think I see where you're going, and I do believe it would work. And you're probably the first person that's ever said this to me. Now, by divide into the answer, what do you mean?
Like, divide, get 2 out of y, make the answer 10, and then divide 5 from y, and make the answer 4, and then you multiply by negative. Like,
Divide
like
divide
regular
to 5y.
I say leave those
Divide
there
the
and
5 and then put it on
Yeah,
the
leave
table.
it by 5. Have to go up there and do it. It's like you're just solving it.
I mean, I know, I do understand the division, I understand the division thing, but I'm not seeing the way you're phrasing it. If what I'm thinking you're thinking is what you're thinking you're thinking.
So, divide by 2. Which makes the.
Now, stop. I just need to know. That's what I thought you were thinking, but the deal is this. If you divide one thing by 2, you have to divide everything by 2, so you'd also have to divide this by 2.
Plus 1. 10, and then I do it on this one too.
So if you'd use a 5.
Yeah.
But you gotta do everything by 5.
So, and then x, y. 4. And then I just multiply this
Oh, we're doing a lot of
by
multiplication here.
negative 1.
And then you get
4x
4x minus y.
equals negative 10.
Look at this guy.
Negative x.
This is becoming like a mathematical sort
Plus
of.
4. And then 4x minus 3x. Cross out. Negative 10 plus 4. Negative 6. Divide by 3. X equals negative 2. And then you plug it in.
Now, that would be perfect. Okay, I've never actually seen anybody see it that way, but that does work. This, you can do it that way if that kind of floated your boatage, which I'm sure it would. I need to get back to this. This is what, I hate to erase all of your work. That would absolutely be a way that would work. However, you may not always get something where they're all divisible by 5 like those two were. So this is what the book would tell you to do. Okay, again, your way is where I actually love it because that's kind of cool. What they would say is take a look at 2 and 5, for example. What is the least common multiple of 2 and 5? What's the smallest thing they both go into? If they were bottoms of a fraction, what would you make the bottoms of the fractions? 10. So if you can make this a 10 and you can make this a negative 10, thing's gonna be true. So I multiply the top all by 5. And because I want this to be a negative 10, I could have multiplied either one by negative, but I would multiply the bottoms all by negative 2s. And then rewrite the whole thing out. We're gonna get the same answer Liam got. And if you see Liam's way probably actually would be easier on a problem like this, but not always will all 3 of these be divisible by 2 or 5. And this, oh, by the way, that was a 20. So you end up with, I'm gonna rewrite this one here, negative 40x plus 10y equals 100. The second equation turns out to be a positive 10x minus 10y equals negative 40. My phone is ringing, and it could be somebody important.
Secret agent.
Ooh. So it ends up, this would cross off. You're going to be left with a negative 30x equals a negative 60, a positive 60, sorry. And then x would equal, divided by negative 30, divided by negative 30. And did you get negative 2?
Yeah.
Yeah. So x will still equal negative 2. If you saw it this way, and Liam, and your way is perfectly, as long as you multiply or divide both of them by the same thing, you're okay. So either way it would have worked. put -2 in for any of these 4 equations I started with. I don't know which one. I'd probably go this one. Because a -5 times a -2 plus 5y equals 20 is going to give me a positive 10. I'm going to subtract my 10 to get it over there, subtract 10. I get 10 and 5y equals 10, so y equals a positive 2. Now, just for fun, because I know you want me to waste enough time where I say you don't have any homework, just to prove, wait, did somebody say no?
No.
You don't want me to waste time? You do.
I do.
We do.
Just for fun, if we graph these, we should get, the line should cross at -2, 2. Let's look and see. I'm going to use these, this is standard form, cross the y-axis at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Crosses the x-axis at 20 divided by -8 is, somebody say -2.5, thank you for that. -2.5, 1, 2.5. So this apparently is my first line. Hopefully, that's gonna cross, did I do something right? Don't say I'm doing something wrong unless I actually am. You scare me. The next one here crosses the y-axis at +4. 1, 2, 3. I should have left well enough alone. And crosses the x-axis at who? -4? Oh wait, 1, 2, 3, 4. And then if I draw that line there, that's pretty good. I nailed that.
It's amazing, Mr. Ryan. You're such
And
a talented
I'm within some sort of a tolerance. Here's 2, -2 would be kind of risky, but my line obviously, I could have been off just a fuzz off on each one of those. This one might have been, I think that one should have been drawn there. Please leave. No, please go.
But I should. That one's Did you say that's the easiest one of all?